Okay, so the topic of this video is actually take a bunch of characters that we can generate and find out which irreps actually make up this sum. So previously we had made some matrices where the character for the E operation was 3, the character for the C2 operation was -1, this one was +1, and this one is +1. Okay, so I'm going to represent that by something called gamma reducible. Okay, so a reducible representation is going to be some combination of these irreducible ones. So we're trying to go from the reducible to the irreducible. All right, so I'm going to just write down the reducible characters: 3, -1, 1, and 1. And we ask ourselves, what part of this is A1? Well, we don't know. So what we have to do is multiply it by A1 and see what happens. 1, 1, 1, 1. And so you multiply the numbers in the two columns. So this is going to be gamma reducible times A1. Okay, so we're going to use a special circle symbol X for multiplication. It's really not kind of the normal multiplication you can do. So 3 times 1 is 1. Oh, sorry, 3. 3 times -1. Sorry, -1 times 1. -1. 1 times 1. 1 times 1. All right. And the last thing we need to do is actually multiply by the order of the group. 1 over h. Now this has 4 symmetry operations, so h equals 4. So we have 3 minus 1 plus 1. We have 4 divided by 4. Okay, so to recap, we take the reducible characters, we multiply by the irrep we're interested in. We get some numbers, we add them up and divide by the order of the group, which is 4. And we get 4 divided by 4, and get 1. Well, since we were looking at the number A1s, this tells us there's one A1. Well, if you remember from the previous video, we had an A1. It was called the PZ orbital. All right, so you just repeat this process for the rest of the irreps. Okay, so let's go ahead and do A2. Now, we already know in advance that there is no A2s in this because there should be a B1 and a B2, but no A2 because this is Z, X, and Y. But let's go ahead and make that change. So it's a real simple edit. I'll just put a little 2 there. And I have to put a -1 and a -1 down here. Okay, and so now I'm going to do the product of reducible. So this line's always the same. This line you change depending on which irrep you're going to do. So instead of having 1s, I have 1, 1, -1, -1. And so the product's 3 times 1 is 3, -1 times 1 is -1. This one now is -1. And this one now is -1. And now let's see what happens to the sum of these guys. All right. Well, 3 minus 3 is 0. Okay, so we get 0 divided by 4 times 1/4. Sorry, 0 divided by 4 equals 0. Hopefully you can figure this out. 0 A2s. All right. So I'm going to do one of the other examples, and you should be able to show for yourself that the very last one you should get a 1 as well. So I do want to point out, as you're doing this, you should never get a fractional number of A1, A2, B1, or B2. You'll get something like there's 0 of them, or there's 1 of them, or 2 of them, or so on. Now, this is not true mathematically in general, but for chemistry applications, this should be the case. All right, so let's go ahead and do the B1. So we'll go ahead and make that a B1. And go ahead and leave these erasures in there. They can see. B1 has a 1, a -1, and a 1, and a -1. So we'll go ahead and I just want to show them how easy it is just to do the same thing again and again and again. All right, let's make sure that's B1. There we go. 3 times 1 is 3. Minus 1 times minus 1, plus 1. 1 times 1, plus 1. 1 times minus 1, minus 1. And now the sum is going to be 4. And now there is 1 B1. All right, so that was the number of B1s. All right, so just to recap, take the reducible times the irrep you understand, add them all up, divide by the order of the group, and get how many there are. All right, so last thing I want to do is actually go at it from the reverse. I want to take B2, B1, and A1 and add them all together. So A1 plus B1 plus B2. All right, so we've already shown that there's an A1. We just showed that there's a B1. We've shown that there's no A2, so we don't write it in our sum. And we already know or suspect that B2, there's going to be one of them. Let's go ahead and do the sum of these guys. So 1, 1, 1, 1 for E, C2, sigma, sigma prime. This is the A1 line. I'm going to add the B1 line, which is 1 minus 1, 1 minus 1. And I'm going to add the B2 line, 1 minus 1 minus 1, 1. Let's add these three up. We'll get 3 minus 1 plus 1 plus 1. And look at there. It lines up exactly to what we got. Amazing. So that's actually how you can check your decomposition. You take the things that you think it's however many of each irrep, add them all together, and you should get your original reducible characters back. That's it. Done.